All right, today's video we are going to take a look at solving systems of linear equations. I've split this up into several different examples depending on what you see in the problem that would indicate that one method might be easier than another one to do. First one we're going to take a look at is substitution, and our indication that substitution might be a good idea is when one of our equations just says y equals or x equals, something that indicates directly what that one variable has another name. In this case, the other name for y is 2x minus 5. So what we're going to do is we're going to rewrite the second equation. We take the 3x as it is, and we're going to subtract 2 times the other name for y, which is 2x minus 5. So we'll put that 2x minus 5 in parentheses because it's 2 times what y is. And then we'll grab the equals 16 there as well. Now we're down to a single linear equation with one variable. We solve that like we always would. Gives us a negative 1x plus 10 is equal to 16. So negative x is equal to 6. And x is negative 6, which is part of what we need, but we also need a y. The good news is we have that original first equation that said y is equal to 2 times whatever x is, and we now know that x is negative 6 minus 5 to complete that first equation. All right, this is this equation with an x value substituted in, so that gives us a negative 12 minus 5, which is negative 17. And the way that we would normally write the answer then, because graphically this is a point of intersection between these two graphs, and the x value is negative 6 and the y value is negative 17, and that is where those two graphs intersect. All right. The next type of equation that we have is another systems, but it doesn't directly say x equals or y equals, but we do have x showing up just by itself there, so we could change this equation into one that says x is equal to 13 plus 3y, and now we have an x to replace the x in this second equation. So we rewrite our second equation with 6 times what x is, that's 13 plus 3y, and we finish out the rest of this equation. Plus 5y is equal to negative 14, down to just a single variable again. So we distribute through here. We get 78 plus 18y plus 5y is equal to negative 14. This gives us a 23y is equal to negative 92. And y then, if we divide by 23 on both sides, we get y is, what's that, 4? Negative 4. So we know that the y is negative 4, and now we can go back up to this equation that we have here again to figure out what the x is that goes with it, because it says x is equal to 13 plus 3 times whatever the y is, and our y is negative 4. So x is 13 minus 12, and that's 1. And so we record our answer again that x is 1 and y is negative 4. This would be a fairly easy thing to check as well. We could plug these 1 and 4, x equals 1, y equals negative 4, into both of these equations up here and verify that it works for both of them. But I'm trying to keep the length of this video down a little bit, so I'm not going to check those right now. Our next method is what we call elimination, and what we look for in elimination is a way that we could combine the two equations and a variable would disappear. So what we see on there right now is I've got a positive 4x and a negative 4x, So if I were to add these two equations together, the 4x and the negative 4x would cancel each other out. I'd be left with a negative y is equal to 4, which tells me right away the y must be negative 4. Still need to find the x, so I pick one of those equations. If I pick the first one, I could say that 4x minus 3 times y, which I now know is negative 4, is equal to 14. So 4x plus 12 is 14. That means 4x is 2, and dividing by 4 on both sides, x would be 1/2. So my answer, again, is the x value, comma the y value. This is the point on the graph where those two lines meet. It's the only place where those two lines meet. Okay, so that's the first of our elimination type of problems. We're going to look at a second type here where I have a 6y and a 6y, but they're not opposites. So my options here are either to subtract, though I find that to be a little bit dangerous sometimes. So what I'm going to do is I'm going to multiply this top equation by negative 1. Everything in there by negative 1. That's going to create a positive 2x. A minus 6y equals negative 12. And now I have those opposites showing up, so I can add together and I will get 7x is equal to negative 28. So x is negative 4. And again, continuing on with what I've done before, now that I know the x is negative 4, I'll take the second equation this time. 5 times negative 4 plus 6 times y is equal to negative 16. So negative 20 plus 6y is negative 16. Adding 20 to both sides, I get that 6y is equal to 4. So y is 4/6 or 2/3. And I have my 2 points again, the x being negative 4 and the y being 2/3. That is where those two lines meet. And our final example here is going to be one where we don't see anything matching up at all. So we have to make adjustments to both equations. I'm going to drag these down over here to work on them here. So what I have to do now is I'm going to decide on a variable that I want to get rid of. So these are already at least opposites here. So I'm going to get rid of y. But in order to do that, I have to make the coefficients of the y the same, but with opposite signs. So if I multiply this top equation by 4, that's going to change that into an 8x minus 20y is equal to 60. And if I multiply this bottom equation by 5, that's going to give me a 15x plus 20y is equal to 55. And now I have these pieces here that are matching up, so I can add these two equations together. That will give me a 23x is equal to 115. And if I divide both sides by 23, I get x is equal to 5. And now that I know the x, I can grab one of my original equations. I'll take this first one right here, and that's 2 times 5 minus 5y is equal to 15. So 10 minus 5y is equal to 15. Negative 5y is equal to 5, so the y must be negative 1. And my answer is that these intersect at x equals 5 and y equals negative 1. And if you're in my class and hopefully watch this whole thing and see the note at the bottom here, If you watch the whole video, grab yourself a Post-it note, write "Go Cougs" on it, put your name on there, and turn it into me tomorrow. You can keep your note page, but that will get you some extra credit for having watched the whole thing.